So let's talk about the types of probability distributions. Now, first of all, probability distributions can be broken down into two parts. One of them can be called probability distribution from discrete random variables, and the other can be called probability distribution from continuous random variable. So here we have two types of probability distribution tables. One is probability distribution table from discrete random variables, and another is probability distribution from continuous random variables. It all depends on the random variable. Now, first of all, let's talk about the probability distribution for discrete random variable. Now, discrete random variable, when we talk about the types, there is the first type. Let's call it the general distribution. So this is the general discrete distribution. So it means it is not anything specific, it's the general distribution. Now the next one is called the uniform distribution, uniform discrete distribution. Uniform means equal. All the probability of this distribution are equal, like throwing a die. The probability of 1 is 1 by 6 because favorable outcome is 1. There's only one 1 in a dice, and there are a total of 6 numbers, so 1 by 6. The same with all the others. The probability of throwing a 2 is 1 by 6, 3 is 1 by 6, 4 is 1 by 6, and so on. So all the probability of a distribution like that is called the uniform distribution, and the random variable is discrete. It can be counted 1 2 3 4 5 6, so that's why it is discrete. The next one is, and these two are more important. One of them is called the Poisson. Poisson is a French word, is Poisson. Instead of that, we can call it Poisson. Poisson distribution. And the other one is the binomial. Bi means two, binomial means two things, distribution. So the general distribution and the uniform distribution, they're just an overview, but the main thing is the Poisson distribution and the binomial distribution. Now let's talk about the probability distribution with continuous random variable. So first of all, we have similarly a general continuous distribution, which is an overview of everything, and we have a uniform continuous distribution, which is also where all the probabilities are equal. But here the most important concept is the normal distribution. So that doesn't necessarily mean the other distributions are something strange or abnormal. Normal distribution means it's a name because it's something that happens. in a special way, so we call it a normal distribution. Now the first question that comes to mind, why do we need to have so many different types of distribution while we're talking about distribution? Why not have just one distribution for discrete random variable probability distribution and one for discrete continuous random variable probability distribution? Now the question is, when we have to think about a tool, suppose a screwdriver, we have different types of screwdrivers for different purposes. There can be a flathead for opening a different type of screw. There can be a star screwdriver for which is a bit different. Then there can be a tester screwdriver which has some sort of a electric, it can measure, a light goes on, so it can measure whether there's electric current going on. So different tools have different purposes. Similarly here, the probability distributions, be it discrete or continuous random variable, they have different types. You see that both has general, they need some sort of a general distribution, and both has uniform, they need that. But they have discrete distribution, we have Poisson distribution, then we have binomial distribution, normal distribution. Why do we need to do that? So what are they? Now to give an overview of this, first of all, the normal distribution is perhaps the most common and most important. It is extremely important, and the normal distribution is a distribution for which we need two parameters. Parameters means an external value, an outside value. So for the normal distribution, we need the mean of the distribution, and we also need the variance. Variance is the square of the standard deviation. So another name for the variance is the square of the standard deviation. So for that we need the mean and the variance. For the binomial distribution, we need two things, which is number of trials, meaning how many times you do a certain things, you repeat it, like tossing a coin, how many times you toss a coin, that's called the number of trials, and the probability of success. Success meaning the probability of what you want. If you want something, what is the probability of that happening? Suppose you want a head, and the probability of having a head is 50%, and now you know you're going to toss the coin 30 times. So the number of trial, also given by the symbol n, and the number of success, the probability of success given by the symbol p, that denotes that. And in case of Poisson, it is also the mean. What is the mean of something happening? Now when we talk about probability distributions, we have to express it, because after all it's math, it's symbolic language. We need to express it in some way. So this is how we express probability distribution. First of all, we write a random variable. Let me use the symbol random variable. Then we give this wiggly type of a shape, which refers to this random variable belongs to the probability distribution. Then we give the name for the distribution. So this is the name for the probability distribution, right? Then we give a bracket and put in any values, those external values. It can be one value or it can be two value. So for example, in binomial distribution we need two values, in normal distribution we need two values, but in Poisson distribution we need only one value. So these are called the parameters, the outside values. Parameters. So that's how we write it. So when it comes to writing the normal distribution, first of all, the symbol for population mean is this thing, mu, and the symbol for population variance is standard deviation whole squared. Standard deviation is sigma. This symbol is called sigma whole squared. So first of all, how do we write the normal distribution in symbolic form, in mathematics forms? First of all, we write the random variable. So let me call all the random variable capital letter X. So we write this, then we give this belongs, and the symbol for normal distribution is n, and we write the mean, and then we write the variance, which is standard deviation whole squared. In case of binomial, again we write the random variable first, which is capital letter X, then we write the name of the probability distribution, which is binomial, the symbol for which is b, then we write the parameter n first, and then we write p, the probability of success. In case of Poisson distribution, we write first of all the random variable x, then we write the symbol for Poisson, which is po, so that it does not get confused with probability, because symbol for probability is also p, so po Poisson, and the symbol for mean we write mu, or sometimes it is written as lambda. Both is valid. So these are the different types of probability distributions, and how do we express them. Now in case of general discrete distribution or general continuous distribution or uniform, since they are general and uniform, so they cover everything, so we don't need to use a special symbol for them. So these is the different types of distribution. These are tools, we use them to find various values. And one more thing that must be talked about, that what are the things that we should know about the distribution, what we should know how to find. So these are the things that we should know how to find. One thing is any constant, what we need to find from a distribution, what we need to find. So first of all, we need to find any constant. You remember that total probability is 100%. So remember, so whenever you're talking about probability, you can just add it up and you'll get 100%, and from that equation you can find something constant. The next thing you need to know is probability. The main idea after all is, if you have this distribution, what is the probability of this thing happening, what is the probability of that thing happening? So that is very important. Now another thing that you need to find is called the mean of the distribution, also called expected value. Another name, expected value. So whenever we are talking about the mean of the probability distribution, it is called expected value. And the final one you need to know is the variance. A variance is nothing but standard deviation whole squared. So these are the questions that are most commonly asked in exams. So you will be asked to find this and how to deal with them.